Hello, my name is Fred Trotter.
And I am Victoria Hernandez, and we are both data journalists at CareSet.
So today we're going to be reviewing the COVID-19 Community Profile Report that was first released on December 18th, 2020. We're going to be looking at the December 17th edition of that file from the same year, which is the first file that was ever released. As we do that, as we said before, we are with CareSet, and we are a healthcare data journalism organization that is focused on Medicare data. So the hospital oriented data that's in this data set, we're super familiar with. However, we're not as expert at all on some of the other data sets. And as a result, when we made the community FAQ, we collaborated with a couple of other organizations, us, Data Journalism CareSet Systems, researchers from the University of Minnesota COVID-19 Hospitalization Tracking Project, volunteers from the COVID Exit Strategy and COVID Act Now, and then of course, the COVID Tracking Project, which is probably the most important dashboard outside of the one that's used in terms of federal government. So today we're going to be talking about the select high burden information with the core-based statistical areas. And this is what these pages in the PDF look like.
And my first question was, what is a core-based statistical area?
Which is, I think, it was mine too, right? I've been working with geodata a little bit longer, so these statistical areas are kind of complex, and there's multiple statistical areas, all of which are managed by the Office of Management and Budget, and the census essentially is where these things ultimately are sourced from. And basically, when you study cities in the United States, you can't aggregate them as a subpart of states. You can't, for instance, with especially for cities like St. Louis or Texarkana, where you have half of the city is across state lines. You can't just look at the Texas part or the Arkansas part. You have to kind of think of them as one area. And so the way that the census decided to do that is to say, well, if people are commuting in a particular area, so that you transfer from one side of a city to another for work, if that's common, then they put all of the places where that's true inside one area. So it ends up being a really, really accurate model of cities in the United States, but there are some statistical details about how they've done that. And so, for instance, they consider, I believe, Dallas and Fort Worth as one area rather than two cities, and it's precisely because people commute between those two cities all the time for work on a daily basis. So basically, the takeaway is CBSA equals city. And this first slide here, and you can see over here, there's three basic columns: population over 1 million, population between 250 and 1 million. This is medium-sized cities. And then this is not all small cities. It's a very small city, which in this case would be defined as under 50,000. It won't show up on this chart at all. But for cities between 50 and 250K, this is on the right.
Why doesn't it show up at all?
I think it's because if you really think about small cities, you can have a very small city that's hit hard by COVID. And even though it would float to the very top of the list here, it could only be 50 people who's infected. And so again, this dashboard is used inside the federal government to make decisions. And so from their perspective, they really want to talk about large groups of people. And the other thing is that the data about very small cities, and really everyone who's been hit hardest, you can do that by sorting on the columns in the Excel version of this same data report. So that's actually an important distinction, is that this is the PDF edition of the report. And the advantage of the PDF edition in the report is that it shows stuff that doesn't. In fact, you were going to explain what those little charts are. Can you explain what these are?
Yes, so those are going to be spark lines, and they go back 8 weeks. And so you can see the trends of the high burden cities and the cities that are having increasing burden, which you switch to the next. Are we ready to go?
Yeah, I think we can go to the next slide now. So the next one is essentially the same chart.
Yes, but they're the cities with increasing burden. So not only is it bad now with COVID, the trends are showing that it's going to get worse.
Yeah, and it's easier to see here when you scroll up again and you just glance back at this after having a look at it. You can see here that on this chart, and I apologize, I have to look at the screen in front of me because I can't read the screen that's here in the studio. But Las Vegas was here on this chart. Indianapolis, Cincinnati, and Cleveland and Columbus, Ohio are all there. And these little green blocks here indicate that they are bad. They're being hit the hardest on this particular week that this day's data is, but they are getting better. And you can actually see this happening a lot over here in the middle column. It's worth noting here that this is immediately a difference between how it's hitting small towns and how it's hitting big towns. None of the cities over here, except for possibly, I think that's a small city in Idaho, is getting better. And so as we scroll down here, you'll notice that all of the greens have been removed. And so now what we're doing is we're saying, all right, let's look at the places where COVID is really bad, and also it is getting worse. And so when you look at it here, and again, all of this data is in terms of cases. So these are the number of cases, which is, I think, the leading indicator, right? So testing is really hard to interpret. Mortality is super easy to interpret, right? Somebody dies, that's the worst case scenario. But cases is a leading indicator of who dies. And so all of these things are in terms of new cases, which is the reason why they talk about the burden, right? This is really where the problem is. Cases is the most central measure for that. Do you have any more questions about this?
No, but I would like to point out to people watching that the spark lines are available in the PDF. You will not find that in the Excel edition.
And that's right. And the other side of that coin is you will find all of the rows for every CBSA in the Excel edition, but you will only find these kind of top level buckets here. So again, this is a perfect example of how you need to use both files together if you want to really understand the perfect picture. The PDF has the spark lines, Excel has all the data. I think that's probably it for these two slides.
Yep. Thanks.